Hello dear students, a very good evening everyone. Welcome to the session and welcome to the special classes of signals and systems. Yes, the special classes because they are special because we are going to, in this particular series, we are going to discuss the questions that is from the one of the best books of signal and system for your gate preparation, and that is the Oppenheim and Wilsky. The Oppenheim and Wilsky. All right, very good evening Komal, good evening Kumar, very good evening all. So come on, quickly update your friends that the session is live and let's discuss the question, okay, from this particular book, that is the Oppenheim and Wilsky. Okay, one of the best books for signal and system preparation. Okay, it covers up everything, almost everything for gate syllabus. Of course, some topics are not there, that also I will guide you, but most of the syllabus of gate, and that to the level of questions that is in there in the gate, the type of understanding that you need to have for the gate exam is everything in this books. And I thought, let us discuss, okay, some unsolved problems of this book. Okay, the questions, okay, the unsolved questions of this books we shall going to discuss here. Right, very good evening Ananta. Okay guys, all set? If all set, let's get moving ahead, let's get started. Okay, so this is a different sort of initiative taken by me, and now Sanjay Rathi sir will also join. After some days he will take up the problems from Sadiku, the network. One of the best books of network is like Sadiku. He'll be joining, okay, to take the classes, to take the questions from the book of Sadiku, again chapter by chapter. Okay, so the chapters that we are going to discuss will exactly resemble the name that is printed on the book. That is chapter number 1, basics of signal and system. Next class will be chapter number 2, LTI system, and etc. Okay, so very honestly, it's a new initiation. Okay, if students are interested, we will carry forward. Okay, I am planning to complete all chapters of this particular book. Okay, some questions daily. Okay, of course we can't solve 100% questions here, we don't have that much of time and bandwidth. Okay, but daily we'll take up some time on the YouTube. Okay, and then we'll discuss up one by one, chapter by chapter. So okay, one session for one chapter. Okay, but let's see how much the students are interested. If your interest is there, we'll complete all the chapters definitely. Okay, so let's get started guys. Okay, so guys, the PDF of today's class along with the detailed solution and concepts whatever we are discussing, okay, like all other classes, I'll share this PDF as well. And other than that, for updates about my classes, for updates about gate exams, PSU notifications, for doubt discussion, etc., you can be connected in my Telegram group. Daily 1.5 hours. It's to be honest, not daily. We'll cover it on MWF basis, Monday, Wednesday, Friday, because I have other sessions also parallelly going on the app and on the paid batches. Okay, Venkat. Okay, so we'll take it Monday, Wednesday, Friday, and I think that is sufficient. If required, we'll increase the frequency. Okay, it's like today's chapter 1 number 1, chapter number 2 will come on Wednesday. Okay, ji. Chalo, so let's get moving ahead. So what I have done is, even for this particular session, I have not even got the questions typed. It's very easy to get them typed, but I'm bringing the exact question of Oppenheim with the question numbering. Okay, some from the basic section, some from the advanced section. There are two types of problem in the Oppenheim: basic problems and advanced problems. Okay, and even most of the basic problems are relatable with gate. Gate mein hota hai, suppose sometimes in gate 10% problems come to be tough, they can be related with the advanced problem. So we are taking both. Good evening, Dreamer. So number 1, a continuous time signal is as shown in the figure P1.2.1. This is the figure P1.21. Okay, sketch and label carefully each of the following signals. Sketch and carefully label carefully, label and all. See, the question of the books will be looking like a conventional format. Sketch karo, label karo, but you know what you require for gate. Okay, we will solve it up to the extent that is sufficient and relevant with the gate exam. Okay, good evening Bhanu. Okay, so now number 1, yeah, number 1 is done. Okay, we are not going to do number 1, xt minus 1, just right shifting. Okay, I hope you are all aware, xt minus 1 is nothing, right shifting, so that you all can handle. Okay, forget that. Okay, let us come to the next important part, x of 2 minus t. Okay, ye sab kar lenge na, just 1 unit right shifting. Okay, now x of 2 minus t. Okay, here, what is the rule you follow? Always be careful about the precedence rule. You can shift and scale, as well as you can scale and shift. Both are okay. Okay, but what to follow so that you don't commit errors. By chance bhi mistake na ho jaye. Okay, good evening, Janet. So, dekho, let's start with the first one. And what is the first one? The first one is x of 2 minus t. x of 2 minus t. Actually, the b part, a part I'm assuming it is done, okay? A part I'm assuming it is done. So x of 2 minus t, x of 2 minus t, so that is x of minus t plus 2. Now, I'm telling you, you can shift first and scale, or you can scale first and shift later. Both are absolutely okay, but the method to shift first and then scale, which I call it as precedence rule, is a method where you will not commit the errors. Okay, where you will not commit the errors. In the other one, once you scale first and then shift, the probability of error is more with the students. ठीक है, तो चलते हैं shift and scale की तरफ. So when you are going to shift, okay, Fourier transform पे भी आएगा. Every chapter Vikram we are covering. Every chapter we are covering. That's what I told you, na? LTI system, Fourier series, Fourier transform, Z transform, Laplace transform, DTFT, everything we are covering. All chapters which are there with the gate syllabus we are covering from this book. ठीक है, तो x of minus t plus 2 है. Okay, so now when you are going to shift, the fundamental is, okay, the fundamental is कि when you are going to shift, forget the scaling factor. Forget the scaling factor. Okay, like scaling factor here is minus 1. Minus 1 means folding. Scaling can be what? Scaling can be, okay, either compression or expansion, or if you take alpha minus 1, that is just folding. Okay, so I will remove the alpha factor. I will remove the alpha factor. Okay, this is resembling to x of alpha t plus beta. Okay, so forget the alpha first of all. So x of t plus beta, x of t plus 2. Can you draw x of t plus 2? Left shifting dear, left shifting IA. Okay, left shift the waveform by 2 units. Let's do it up. Left shift this waveform by 2 units. Okay, ये लीजिए sir, by 2 units. So it is going to start with minus 4. Okay, minus 4. So this will be minus 3. Everything will be 2 units left shifted. Okay, the origin activity will be seen at minus 2. Okay, then the value will go to 2. Okay, 1 wala void point will come to minus 1. Okay, and then the signal is going to end at 2. The signal is going to end at 2. Something like this. Okay, so this is what, minus 4, this will be minus 3, this will be the minus 2, this is minus 1 and origin. This is left shifting dear. This is left shifting. Okay. Now, what is the next step? This is only x of t plus 2. Now you have to do x of minus t plus 2. So what is the meaning of x of minus t plus 2 now? Okay, so this was only left shifting. This was 2 units left shifting. What will you do now? T replaced by minus t. T replaced by minus t means? T replaced by minus t means what? Mirror image. So now you have to just take the mirror image of this waveform. Okay, so everything is on the left, that will come to the right. Okay, right mein 0 hai, so left will be 0. So just take the mirror image, copy it. Okay, something like that. Okay, so just copy it here on a different waveform. Copy means just create the mirror image of it. Okay, so this will be known as the 4, this will be 3, 2, 1 and 0. Okay, please check your answers. Please check your answer. This is x of minus t plus 2. In the gate exam, you will be given the options. You can match the options. Okay, you can match the options. Okay, chalo, next question. Okay, next question. See, x of 2t plus 1. With one question, you will be really good with the sketching part. Okay, it has almost everything. X of 2t plus 1. Okay, x of 2t plus 1. C part पे आ जाएंगे dear. X of 2t plus 1. Okay, again x of, it is like x of alpha t plus beta. So what will I do? What will I do? I will remove the alpha. I will remove the alpha. पहले alpha को हटा देंगे. I only want x of t plus 1. I only want x of t plus 1. Okay, sir. So I will just start sketching what? I will start sketching the x of t plus 1. And what is x of t plus 1? Left shifting again. T plus means left shifting by 1 unit. You just have to left shift this particular waveform by 1 unit. Okay, so minus 2 point will start from minus 3 actually. Okay, this will come to the minus 2. Okay, then there will be this step. Okay, this will raise to 2. It will come down. And it is going to go up to the 1. This is 0, this is minus 1, minus 2 and minus 3. Just the 1 unit left shifting, okay? Okay dear, just the 1 unit left shifting. Just the 1 unit left shifting. Bhanu, you can feel around 9-10 will be there. I forgot the number, but around 9-10 is there. Okay. Every chapter of Openham will be covered. okay, which is there in the GATE syllabus. Okay, so almost 9-10 will be there, provided you are all regular and sincere. Since this is a new initiative, okay, I want to see that strength going on. Okay, I will carry forward this initiative once the students demand it. Okay, so abhi I know initially few days everybody will be there. After some days students are tired, very easily students are tired. So I don't want to see that attitude. Okay, I just don't want to see that attitude. Chaliye, now next step. Next step mein I want x of 2t plus 1. Now I will sketch x of 2t. Now dear, whenever t is replaced by 2t, so that means what? Whenever this t is replaced by 2t, so that represents compression. Okay. Whenever your scaling factor is greater than 1, okay, it represents compression. It will represent always the compression. So you have to compress. Compress means small, shorten the waveform in time axis, divide all the values of time by 2. Okay, so minus 3, okay, the point minus 3, origin remains to be origin. The point 1, that will come up to the 1 by 2. Okay, the point minus 1 will come to the minus 1 by 2. Minus 2 by 2 will be at minus 1. And the waveform starting at minus 3 will actually start at minus 3 by 2. All values of time compressed, that is divided by 2. Correct, Ananta? Okay. That's what Bhanu I told you. Na? Immediately in some days, just in some days, you will see Sanjay Rathi sir also coming up with network, Sadiku. Okay, the good book for network, that is a Sadiku. Okay, then we will discuss for others also. Okay, then we will take up the others also. Okay, so dekho, have a look into this. Okay, the waveform shape is same, it is just compressed in time. It is just that it is going to be compressed in time. Have a look into this and match your answers. Okay, no, not minus 1 to 1. Venkat, it is minus 3 by 2 to 1 by 2. Divide by 2, minus 3 by 2 up to the 1 by 2. Up to the 1 by 2. Okay? Done. So first shift. So when you're shifting, you forget this factor. Only t plus 1 or t minus whatever. Then t replaced by 2t, and that is compression actually. Okay? Next question. Okay. So we are done with the up to the C part. Okay, B is done, C is done. Okay, let's come to the D. X of 4 minus t by 2. X of 4 minus t by 2. Isko bhi dekh lete hain dear. Okay, x of 4 minus t by 2. What is this? Chalo, let's come to the D part. X of 4 minus t by 2. So this is like, first of all, x of minus 1 by 2t plus 4. X of minus 1 by 2t plus 4. And once again what I am telling you, what is that minus 2? Okay. Same type means similar types on the other. So what is this now? Okay, here only thing is it is folding also and it is expansion also. There are two parameters of alpha, but सबसे पहले तो क्या करेंगे? Remove whatever alpha, positive, negative, remove. You have to draw x of t plus 4. You should focus x of t plus 4. 4 unit left shifting. Okay, it has to be 4 unit left shifting, and because it has to be 4 unit left shifting, okay, इसको थोड़ा सा और left तक लेके चलते हैं. It has to be 4 unit left shifting. Okay, so I'll draw the waveform slightly carefully. 4 unit left shifting means you have to go till minus 6. Okay, t plus 4. Okay, then suppose this is the minus 5. Okay, suppose this is the minus 4, minus 3, minus 2, minus 1. थोड़ा सा और carefully. Okay, so this is what it is. Clear? Okay, left shifted by 4 units. Clear? Now please pay attention. What is the next step? X of minus 1 by 2t plus 4. Now what does it mean? T is replaced by minus 1 by 2t. Minus 1 by 2t. That means now you can do it in 2 steps or you can do it in 1 step also. What does it mean? Minus t means folding. Minus t means folding, but at the same time it is not only folding, it is t replaced by t by 2, t by 2, scaling factor 1 by 2, Scaling factor 1/2 will be expansion by 2. So all the values of time will be multiplied by 2 and also going to the right side. Okay, going to the right side. So I think इस diagram में नहीं आ पाएगा. Okay, इस diagram में नहीं आ पाएगा. Let me take up a fresh page here. Okay, dear. Let us take up a fresh page here and try to draw it. Okay, so I'm going to draw in one single step x of -1/2t plus 4. Okay, so -2. See now, -2 will go to 2, but because of expansion, it will go to 4. It will go to the 4. Okay, -6 will go to what? Okay, -6 will go to what? Okay, -6 पहले जाएगा 6 पे because of folding, and then because of expansion, it will go to the 12. So 4 to 12. Okay, you should be taking the waveform from 4 to 12. Okay, from the 4 to 12. Okay, this width was 1, it is expanded and now it becomes 2. Okay, it is expanded, now it becomes the 2, and इसको पूरा का पूरा fold भी कर देना है. Okay, so this is going to increase. Okay, then you have a height. Okay, this goes to 6, then this will go to the 8. Okay, drop. Okay, it will drop, and then this is going to go up to the 10. Okay, and then it will drop here, and then you will have a decreasing line. This is how it is going to look. This is 1, this is 2 units. This is how it is going to look, dear. Please check out your answer. It is going to be from 4 to 12 and with this particular waveform. Okay, just kindly check out your answers. Okay, just kindly check out your answers. Okay, if it is all good, okay, if your waveform is matching, it's really good, and you can press your attendance by hitting the like button if you have got the waveform correct. If you have got the waveform correct. Done hai? Yes hai? Chalo, what is the next part then? Okay, so we are done with the fourth as well. Okay, now xt plus x minus t whole multiplied by ut. Whole multiplied by ut. ठीक है? Whole multiplied by ut. xt plus x minus t whole multiplied by the ut. आ जाते हैं उस पे. Okay, the next part. Okay, that is the e part, xt plus x minus t, and that is the whole multiplied by ut. Ab actually x minus t, what is x minus t? Mirror image. Okay, but what is the mirror image? Okay, whatever is the answer, xt plus x minus t, you are going to multiply by ut, and what is the multiplication by ut means? If you are going to multiply by ut, only the right hand side portion will be left. Because when t less than 0, ut will be 0, so everything gone away, multiplied by 0. So whatever is the answer, only right side, that only you should concentrate. That only you should concentrate. Okay, so what will I do? Okay, this is the xt, right side mein, this is the xt. What about x minus t? Okay, what about x minus t? इसी के ऊपर overlap कर लेते हैं. Okay, if you want to draw the x minus t, take the mirror image here only. Okay, take the mirror image here. ये आया. Okay, then it goes down. Then it goes down. Okay, then this is the mirror image actually. This is x minus t. Clear? This is x minus t, and only focus on the right side. Only focus on the right side. Okay, now superimpose. Now you have to add. Now you have to add. So this is 2 and this part is 1. 2 plus 1 kitna milega? That will be 3. Okay, so between 0 to 1 you should be getting the 3. Okay, between 0 to 1 you should be getting the height that is equal to 3. That is equal to 3. Okay, now look into these two. ये थोड़ा सा ध्यान से आपको समझना पड़ेगा. What does this mean? It is a straight line. Okay, having the slope negative slope because it is decreasing. Base is 1, height is 1. Okay, base and height दोनों 1 है. So what is the equation of this line? Okay, y equal to mx. Okay, y equal to mx. Sorry, it's with respect to t. Okay, so minus t, slope 1 unit, magnitude 1, height upon base 1, but decreasing line hai. Okay, now because the slope is 1, if I take another 1 unit, another 1 height will increase. Okay, another 1 height, it is going to touch the 2. That means what is the y-intercept? The y-intercept will be equal to 2. Y-intercept will be 2. Y equal to mx plus c apply kiya. Y equal to mx plus c. ठीक है. Now, what about this equation? What about this equation? देखो, this is also decreasing line, तो negative slope. Okay, base 1, height 1. So magnitude of slope 1. So it is also minus t. Minus t plus what is the y-intercept? What is the y-intercept? तो इसको थोड़ा सा लेफ्ट की तरफ लेके जाओगे, because the slope magnitude is 1, so base 1, तो ये भी height 1. So it is going to touch the y-axis at 1. At 1. Okay, so minus t plus 1. So I can say that, have a look into this calculation dear, that when the time value is between 1 say 2, I'm talking about the time between 1 to 2, you will have minus t plus 2 added with minus t plus 1. Okay, that looks like minus 2t plus 3. Minus 2t plus 3. Okay, minus 2t plus 3. अब आ जाते हैं. Okay, this is t equal to 1. This is t equal to 1. Pay attention. So if I substitute at t equal to 1, everybody see. If I substitute t equal to 1, so minus 2 plus 3, that will be equal to 1. That will be equal to 1. So it should be starting from here. This is 1 unit. Let's say this is 1 unit. Now I have to go up to the t equal to 2. Okay, dear, for t equal to 2, minus 2 into 2, minus 4 plus 3, minus 1. Okay, minus 1. It will be going up to the minus 1. This level at t equal to 2, and then it stops. After the t greater than 2, both are 0, na? So this is the waveform. This is the desired waveform. This one is good actually. This one is good. Okay. थोड़ा ध्यान से देखेंगे तो this one is a good part. This one is the good question. Okay. This one is known as the good question. ठीक है? This should be the answer. Okay. Now this is having the slope what? This is having the slope 2 units, negative 2 units. अब देख भी सकते हैं base 1 height 2, that is why the slope is 2. Automatically you can see that this is the answer. Okay, so I only focus on the right side because of the ut na, because of the ut. Everything else on the left side is 0. Because of the ut, everything on the left side will be 0. Everything after 2 will be 0. This is the waveform. ठीक है जी, this is the waveform. Done है. ये आपका final answer हो गया. Final answer हो गया. Done. So we are done. Okay, we are done with the E part. ये अच्छा था. Okay, this one was good question. E part was good question. Okay, F part, guys, this is a homework for you. F part will be a homework for you because it is just an impulse property. Array, what is that impulse property? I'll give you the hint basically. I will give you the hint basically. Xt delta 3 t plus 3 by 2. X of minus 3 by 2 delta t plus 3 by 2. xt delta t minus t naught, x of t naught delta t minus t naught ना, minus, okay, ब्रैकेट को ओपन करेंगे तो xt delta t minus 2, t minus 3 by 2, तो x of 3 by 2 delta t minus 3 by 2. Okay, x of minus 3 by 2 delta t plus 3 by 2 minus x 3 by 2 delta t minus 3 by 2. That is the answer. Okay, that should be the answer. Clear everybody? Okay, that should be the answer. Now, you know, you only have to work out a small activity. What is x 3 by 2? Okay, what is the value of the signal at 3 by 2? Okay, ये रहा 3 by 2. थोड़ा सा आप slope lope का concept apply करोगे, value आ जाएगा. Very simple it is. Okay, very simple. So this one is homework. One small homework for you. Let's move ahead to the next activity. Let's move ahead to the next activity. चलते हैं. Okay, now next question 1.25 as per the Open and Wilsky book. This is the second edition of the book. Okay, this is the second edition of the book. This one, which I have it personally also. ये तो I have taken this ebook screenshots, the direct screenshot, but this is the book. Okay, which I have it since my GATE preparation time. Okay, I told you one of the best books. Okay, undoubtedly worth of having this book. Okay, I have it since my time when I was preparing for the GATE. Okay. Now determine whether or not each of the following continuous time signals is periodic. If the signal is periodic, determine its fundamental period. Determine its fundamental period. So xt is equal to 3 cos 4t plus pi by 3. Okay. Now see, for some of the signals it is very simple. Na? इसमें तो you don't have to think a lot. You don't have to think a lot. What is the answer? Okay. Yes. Cos continuous time domain है. Cos omega t plus or minus any initial phase also. Okay. This is always periodic, having the period 2 pi by omega. 2 pi by 4, that is pi by 2. First तो simple है. Okay, even e power j omega t. Okay, even the e power j omega t is always periodic with the period 2 pi by omega. Omega is pi. Okay, e power j pi d. So this period is equal to 2. There are some standard results. Okay, you don't have to think about them a lot. You don't have to think about them a lot. Okay, now cos square. Acha, whenever it is the cos square. Okay, whenever it is the cos square, C part पे आ जाते हैं. Okay, you will just apply the identity. Cos square 2t minus pi by 3. What is cos square theta, dear? What is cos square theta? 1 plus cos 2 theta. 1 plus cos 2 theta. So 1 plus cos 4t minus 2 pi by 3. Okay, 1 plus cos 2 theta divided by 2. 1 plus cos 2 theta is divided by 2. Okay, now DC component, a separate, what is this? 1 by 2 plus 1 by 2 cos 4t minus 2 pi by 3. Okay, if a signal is periodic, suppose, what is the role of the DC component? DC component will just uplift the value, uplift or downlift. It is just going to do the amplitude plus minus. Okay, if it's a positive DC component, okay, it will just add up the value. Okay, it will uplift the value, but the nature of the waveform, the repetition will still be there. Actually, all values are added by that constant. Na? So periodicity will still be there. So if there is a periodic signal, you know, and in continuous time, I'm telling you, na, cos omega t, sin omega t, always periodic. In discrete time, the stories change. Us pe bhi aayenge. But this is always periodic. Okay, so half plus periodic signal will be the same periodic signal with the same time period, I mean. So what is the time period now? What is the time period now? It is 2 pi by omega, but omega is 4. Don't use that the omega is 2. Okay, because it is the cos square signal. So answer is pi by 2. Okay, answer is pi by 2. ठीक है जी? The answer is equal to the pi by 2. तो C भी done हो गया. Okay, so we are done till C, A and B, D and E. Okay, यहाँ पे थोड़ा सा property लगाना पड़ेगा. E1. Okay, what is this EV? Okay, ये जो symbol है यहाँ पे EV, any that is representing what? Even symmetric part of a function. What is the meaning of, what is the formula for even symmetric part of a function? It is given by the x of t plus x of minus t divided by 2. It is given by the x of t plus x of minus t is divided by 2. X of t plus x of minus t is divided by 2. Okay, that is the even part of xt. That is what is known as the even part of xt, correct? The even part of xt. Chalo. So now even part of cos 4 pi t ut and sin 4 pi t ut. Let's look into the d and e part now. Let's come here. Okay. Even part of cos kitna hai? 4 pi t, correct? Cos 4 pi t ut should be equal to what? Okay, xt plus x minus t, that is cos 4 pi t ut number 1 plus x minus t, that is cos minus 4 pi t u of minus t whole divided by 2. Okay ji. Okay, but what is cos minus theta? But what is the cos minus theta? It is cos theta. Okay, it is cos theta. It is cos 4 pi t. Okay, so this is also cos 4 pi t, common le liya. So now I am left with ut plus u minus t. Okay, whole divided by 2. Dear, everybody should know what is ut plus u minus t. Okay, dear, what is this expression ut plus u minus t? That is equal to 1. Okay. Okay, ut plus u minus t, right side 1, u minus t, it's mirror image. When you superimpose them, you get a flat curve, that is the 1. Okay, that is known as 1. So the signal is simply equal to half. Ye to ho gaya 1. So 1 by 2 cos 4 pi t. Done hai. Now everybody can tell the time period, na? 2 pi by 4. That is pi by 2. So it is periodic. It is periodic with the period pi by 2. It is known as the periodic signal with the period of pi by 2. With the period of pi by 2. Periodic with the period pi by 2. Done hai? That is the D part. Okay, that is known as the D part. Okay, now next was even part of sine. Okay, next question was even part of sine 4 pi t ut. Okay, let's do this. Okay, so what is the even part of sine 4 pi t ut? Xt plus x minus t again lenge hum. Okay, that is known as sine 4 pi t into ut, that is the xt. Okay, plus sine minus 4 pi t, x minus t karna hai yahan pe, into u of minus t. Okay, that is whole divided by 2. Okay, now this is equal to, okay, sine 4 pi t, but the next part is sine minus theta. Sine minus theta is minus sine theta. So okay, so if you write minus sine 4 pi t, sine 4 pi t the common, but this will be ut minus u minus t. Okay, ut minus u minus t. Okay, that can also be written as signum function. Okay, sine 4 pi t, ut minus u minus t is also known as the signum function. Okay, ab dekho, whether you write it in signum or not, that's okay. Okay, that's okay. But if you want to try, if you try drawing the waveform, okay, have a look into this. Sine 4 pi t ut. Sine 4 pi t ut means what? Okay, ut means right side. So right side mein to sine 4 pi t hai. But left side u minus t, please pay attention. Okay, left side u minus t, what do you get? अगर इसको वापस मल्टीप्लाई करोगे तो you have minus sine 4 pi t u minus t, minus sine 4 pi t, minus sine 4 pi t, minus sine 4 pi t. Okay, so if this is the sine and left side पे u minus t means left side. So see everybody, in left side this is the sine theta waveform na, but I want minus sine theta waveform. I want minus sine theta waveform. It will be on this side. Okay, this is sine 4 pi t and this one is minus sine 4 pi t, clearly telling that the periodicity is lost. Clearly telling that the periodicity is lost. So देखो ना, periodicity का मतलब क्या होता है? Okay, if this was periodic, okay, this should repeat, but that repetition is lost. That repetition is lost. So this has become what waveform? This has become aperiodic waveform. Okay, this is simply aperiodic now. So if it is aperiodic, you can't say its time period. इसका तो कोई time period हुआ ही नहीं. It is aperiodic. Okay, हाँ, previous one was 4 pi. That's okay. Concept पे focus करते चलते हैं. That's okay. Yeah, that was 4 pi anyways. Okay, correct भानु. Correct कुमार. ठीक है. So done है. So this one, okay. Okay, so we are done with E. The period was known. E is also done, but E is actually aperiodic. The E part is aperiodic. Similarly, F पे भी जाओगे, exponential function, that too real exponential function, not the complex exponential function. Okay, here you are getting a real exponential function. Okay, F part में देखोगे तो you have a real exponential function. इसको अगर यहीं पे देखें हम, so if you open it for some values of t ना, for some values of n, okay, suppose it will be e power minus 2t u 2t. Okay, next क्या होगा? E raised to the power minus of 2t minus 1, u of 2t minus 1. Okay, plus 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 plus, and e power minus 80 is not a periodic signal. Okay, it's not a periodic signal. ठीक है? Yes, that's what real है. अगर if it was complex exponential signal, e power j omega t, that is periodic, as I told you with this one. Okay, with the b part. Okay, this is of the form. The b part was of the form e raised to the power j omega naught t plus or minus some phase. Okay, but we know that complex exponential e power j omega naught t is cos omega naught t plus j sin omega naught t. Okay, even if you write signum t as 2 ut minus 1, उससे कोई change नहीं होगा Narahari. That is okay, but that will not change the previous answer. So this is also clearly aperiodic. This is also aperiodic. Okay, this is also aperiodic. Okay, actually whenever the different unit steps keep coming, the exponentials, they will keep superimpose. Okay, the waveform बढ़ता जाएगा, the waveform will superimpose each other. Okay, so this is aperiodic. F, clearly it is aperiodic. Chalo. Okay, let's move ahead to the next question now. 1.26. Now let us see what is the story in discrete time. It is still the periodicity question. It is still the periodicity question, but this is in discrete time. This is in the discrete time. Determine whether or not each of the following discrete time signal is periodic. If the signal is periodic, determine its fundamental period. Determine its fundamental period. चलो आ जाते हैं A part पे आ जाते हैं. Okay, A part में. First of all, okay, in the discrete time domain, sine omega naught n or cos omega naught n is not always periodic. continuous time mein they are always periodic, but discrete time mein there is a condition. Okay, they are not always periodic, they are only periodic if 2 pi by omega naught is rational. Okay, is rational. तो सबसे पहले तो you have to check first option 2 pi by omega naught, 2 pi by frequency, that is 6 pi by 7. So pi to pi will get cancelled. This is 7 and 2 by 6 will be 3 here. So this is 7 by 3. Is it a rational number? Yes. What is a rational number? Any number which can be expressed in the ratio of two integers. Okay, that is a rational number. So yes guys, this one is perfectly rational. This one is rational. इसमें कोई doubt नहीं है. Okay. This one is rational. Okay, but what is the period now? Okay, if the signal is periodic, determine the fundamental period. So what is the period? In discrete time, period cannot be 7 by 3. Okay, period cannot be non-integer. Discrete time is only defined for integral values of time. So dear, what is the period? Okay, what is the period? Its period n will be written as 7 by 3 into k. 7 by 3 into k. Okay, what should be the value of k? What should be the value of k? K can be any integer so that n remains to be integer. Okay. N has to be integer. In discrete domain, the time period also must always be integer. Okay, so what will I do? To convert into the integer, you can choose k3. K को 3 choose किया तो 3 will get cancelled. Okay, so n will be 7. That is the answer. The time period will be 7. The idea is, of course, discrete time is not defined for non-integers. It is only defined for integers. But mathematically, calculation is suggesting that, okay, there can be a time period like 7 by 3, which is not acceptable to us. But suppose if the signal value repeats after 7 by 3. So if the signal value repeats after a particular time, it will keep repeating after that time, no? After every fixed time. So 7 by 3, again 7 by 3, again 7 by 3. It will keep repeating. So 7 by 3 plus 7 by 3 plus 7 by 3 will be 7. So it will repeat after 7 also. And 7 is an integer. So that is my period. That is my period. My period has to be integer. My period has to be integer. Okay? Chalo. Now if you come to the case number B, dear. If you come to the case number B, यहीं पे कर देते हैं. Okay. What is the 2 pi by omega naught? Okay, 2 pi by omega naught, dear, for the case number B is 2 pi by 8. Correct? 2 pi by 8. Omega naught, 2 pi by 1 by 8. Cos omega naught n में omega is 1 by 8. Omega is 1 by 8. Okay, so 2 pi upon 1 by 8. This is 16 pi. Rational or irrational? Tell me. This is 16 pi, but that is rational or irrational? बता देंगे आप लोग मुझे. Rational or irrational? Rational or irrational? Tell me. Pi, is it rational? Pi is 22 by 7. Is it rational? Nah. 22 by 7 is just an approximation to pi. Pi is not equal to 22 by 7 exactly. It is irrational. So wherever pi comes, dear, ध्यान रखना. Wherever pi is left, that is always irrational. That is always irrational only. Okay? That is always irrational. Okay, so this part is aperiodic. Option number B, question number B is aperiodic. Question number B is aperiodic. ठीक है जी? Question number B is aperiodic. ठीक है? चलो. Now next. Okay, cos pi by 8 n square. चलो n square पे बात पे आते हैं. Let us solve the regular cos omega n case. I will come to the C part. First D पे आ जाते हैं. Cos pi by 2n, cos pi by 4n. What you have to do? Cos A cos B से solve करेंगे. Okay, cos A cos B. We'll look about C. Okay, don't comment right now. Okay, yeah, you can comment. Let's see what is the correct answer. Okay, C पे बाद में आएंगे. Let's go to the D. Okay, let's complete the regular. C1 is little bit interesting. Cos pi by 2n. Okay, then you have cos pi by 4n. Cos A cos B. Okay, that will be cos A plus B. 1 by 2 plus 1 by 4. That will be 3 by 4. Okay, plus cos A minus B. Plus A minus B. So half minus 1 by 4 will be 1 by 4. Cos pi by 4n. Okay, and that will be half. Now, addition. Okay, addition है यहाँ पे. First of all, for the first signal, if you do 2 pi by omega naught या 2 pi by omega 1 बोल देंगे इसको. So that is known as 2 pi upon 3 pi by 4. That will become pi cancel, 2 4s are 8, 8 by 3. So what is the first time period, dear? 8 by 3 cannot be the time period, na? Okay, so 8 by 3 multiplied by 3. 8 by 3 taken 3 times. The first time period is 8, like 7 by 3 converted to 7. ठीक है, second case पे आ जाएंगे. What is the 2 pi by omega 2? Okay, that is 2 pi by 4. Pi cancel, it is 8. Okay, 8. It is directly, both of them were rational. Okay, so both are periodic, and this is directly integer. Whenever you directly have integer, then you have to don't do anything. You should not do anything then. Okay, should not do anything then. So I have n1 and n2. Again, both are actually 8 each. Both are 8 each. Achha. So if time periods are same, dear. Okay, time periods are same, dear. यहाँ पे both are having the similar time periods. Okay, so final time period combining both will be 8. Otherwise क्या करोगे? Right, otherwise क्या करोगे? Or the final time period, okay, whenever two periodic signals are added, it is LCM of n1 n2. It is LCM of n1 n2. ठीक है? Or there is another method also. Either you can take LCM or n1 by n2. Okay, you can write it as, suppose, okay, you can simplify it. Simplest ratio is suppose k1 by k2. After you simplify, suppose it is k1 by k2, या कुछ और बोल देते हैं, suppose it is L by m. Okay, so what is the time period? Cross multiply mn1 or ln2. Both are equal. Both will be equal. Okay, तो ये क्रॉस मल्टीप्लीकेशन से भी कर सकते हैं. Okay, हाँ, of course if you go to frequency, that result will be there, Ananta. Okay, HCF, GCD. ठीक है, done है. So D part is also periodic, done है. Okay, so E part पे आएंगे. C part is still there. E part पे आएंगे. Now 3 periodic signals are going to be added. Same result will apply. Same type of calculations we will apply. Let me write down the third, the E part. Xn is given by what? 2 cos pi by 4n plus sin pi by 8n minus 2 cos pi by 2n plus something that is equal to plus pi by 6. That is equal to the plus pi by 6. ठीक है? Okay, अब देखना है यहाँ पे. Okay, so what is the first one? Okay, what is the 2 pi by omega for the first one? 2 pi by 4 is 8. Okay, so first time period is simply 8. Integer आ गया directly. Okay, next is 2 pi by 8, that is 16. This is also integer, so n2 is 16. Okay, third, that is 2 pi upon pi by 2, and pi again cancel, this is 4. So n3 is equal to 4. So what is the LCM of them? ये तो simple हो गया. Final time period should be the LCM of all of them, that is the 8 and the 16 and the 4. Lowest common multiple should be 16. 16 is a multiple of 16 also, as well as 4 and 8 also. The answer is 16 here. Answer is 16 here. Very easily, you don't have to calculate. You're just able to say LCM is 16. Sometimes you have to calculate, so you can calculate LCM also. Otherwise, you can apply the cross product technique also. ठीक है, चलो. So now these are all regular questions you must know. अब आते हैं C part पे. Okay, cos pi by 8 n square. Cos pi by 8 n square. Tell me, periodic or aperiodic? Periodic or aperiodic? Share your opinions. Share your opinions. Please note down. क्वेश्चन कैसा भी हो सकता है. इट कुड बी cos pi by 2 या cos pi n square, cos pi by 4 n square, cos pi by 8 n square. Okay. So some of you are coming up with the answer that it is going to be aperiodic. Guys, this is going to be periodic. Cos pi by a n square is periodic with period that is equal to a. I'm giving you a result. Now let's understand why. Let's understand why. Okay, इसको समझ लेना थोड़ा सा. Let us understand that why. Okay, let's understand that why. Okay. A signal is periodic. Okay, a signal is periodic. Okay, if it satisfies, okay, what is periodicity? If there is a periodic signal, okay, it will satisfy x of n equal to x of n plus n. Okay, yeah, x of n plus n should be equal to the xn. Okay, what I am telling that the period will be a. Okay, yeah, Ananta, considering that only, explaining that. Okay, so if you try x of n plus 8 here, if you try x of n plus 8 here, so देखो what is going to be the result? Cos of pi by 2 n plus 8 का whole square. Cos of pi by 8, sorry, ये है pi by 8. Cos of pi by 8 n plus 8 का whole square. Open a plus b whole square. That is what is the benefit of these good books. You will keep learning new things. Okay, so this is cos pi by 8 n plus 8 ka whole square. That is going to be, open the a square, a plus b whole square, n square plus 64 plus 16n, a square plus b square plus 2ab. Okay, now this will be further cos pi by 8 n square, okay, plus 8 pi. Okay, 64 by 8, 8 is 8. Okay, next 8, 16 by 8, 2, 2n pi, yeah, 2 pi n. Dear, what is the answer you have got is, you have got cos pi by 8 n square plus 8 pi plus 2 pi n. ठीक है, एक्चुअली इसको हम थोड़ा सा सिंपल कर देते हैं. This can be taken 2 pi outside and then you are left with n plus 4. Okay, so dear, what is the x of n plus n? What is the x of n plus n? Okay, you have tried and you have got pi by 8 n square plus 2 pi n plus 4. Plus 2 pi n plus 4. Okay, plus what? Plus 2 pi n plus 4. अब बोलिए, plus the 2 pi into n plus 4. Discrete time, especially this is discrete time. Okay, n is always integer. N is always integer in discrete time. Okay, so n plus 4 is also integer. Okay, so you have integral multiple of 2 pi. And after every integral multiple of 2 pi, cos theta will repeat. Cos theta will repeat. Cos theta plus 2 pi. What it is? It is cos theta. Okay. Cos theta plus 4 pi. What that is? That is also cos theta. Okay. Cos of theta plus 6 pi. Okay. So cos of theta plus 2 pi into any integer. Okay. When you repeat cos theta after every 2 pi, it's periodic only, no always. It is always and always. Okay. It is always and always periodic only. Okay, so because n plus 4 is an integer, okay, this is an integral multiple of 2 pi, so theta will repeat. Okay, so theta will repeat. So what is this? This will be further equal to cos pi by 8 n square. Okay, so what you have got is x of n plus n equal to xn, and hence the signal is periodic. Okay. Period n equal to, I tried with x of n plus 8. So it is periodic with period 8. Okay, it is periodic with period equal to 8. Okay, now it can be any form, cos pi by a n square, cos pi by 4 n square. So that is why directly I am writing it. Okay. Cos pi by 8 whole square into n क्या होगा बता दीजिए. Yes everybody. So there is a question in the doubt box. Okay, उसको देख लें अगर. So if there was cos pi by 8 whole square into n. So what is the meaning of this? This means pi square by 64 into n. Okay, so that is cos omega n only. That is cos omega n only. So 2 pi upon pi square by 64 ले लेंगे. Okay, but there is a pi element left. This is 128 by pi, irrational. Irrational, so aperiodic. Okay. So what you have done, Ananta, you have done the changes on omega, but ultimately it's cos omega n. So same rule will apply. Okay, same rule will apply, and it turns out to be aperiodic because of irrational 2 pi by omega result. ठीक है, ठीक है. Yeah, period is 8. Period is 8. Acha, at the same time, let me add on one more thing. Then we go to the next question. If the question, if it was cos pi by 8t square, cos या sin, guys, whatever result is there for cos will come up to the same. Yes, Vikram, I'm repeating that point only. You have asked the doubt. Good. So if it is continuous time domain, that will be aperiodic, dear. If it is in continuous time domain, वो aperiodic होगा. Why? इसको यहां से समझ लेते हैं. In continuous domain, suppose everything else, a plus b का whole square, that identity will not change. Na? A plus b whole square, all this thing will be same, but it will be a function of time, continuous time. Okay, so here you are going to get t plus 4. But in continuous time, is t is always integer kya? T can be anything, na? Is t an integer? Maybe t can be 0.1. So then you have 4.1 into 2 pi. Then cos theta will not repeat. ठीक है? Problem is, in continuous time, t can take any value. In discrete time, it is only integer. That is why you got 2 pi into integral multiple. Okay, so अगर continuous time का अगर आप देखोगे, so that is going to be aperiodic. Clear? Okay. That is going to be aperiodic. Don't mark the same answer for continuous time. ठीक है? For continuous time, it is going to be the aperiodic. ठीक है? Got it? Okay जी, done है. Yeah. But अगर दूसरी चीज बोलूं, विक्रम and Ananta, in continuous time, this one will become periodic. If it was pi square by 64t, in continuous time, this one will be periodic. उल्टा हो जाएगा, story will reverse. Because in continuous time, cos omega t is always periodic for any omega. There you don't have to check rational, irrational. ठीक है? तो ये एंगल भी ध्यान रखना. ठीक है? चलो now, before I take the next question, okay, before I take up the next question, have a look into this. The National Scholarship Test, okay, for GATE exam is now on 15th October. Yes, guys, if you want to unlock your dream for the next steps in success in GATE, want to prepare with the full-fledged or even crash courses option, okay, so you can, enroll up to the courses and you can get up to 90% scholarship discounts on the courses based on their performance in the scholarship test. BYJU'S exam prep app pe hoga. And also, guys, just 2 days ahead now, 11th October, Wednesday, on the BYJU'S exam prep app. Okay, all your favorite Abhinav Negi sir, MTech IIT Delhi is going to take a free live interactive workshop, and very important at this point of time, the syllabus, the concern of the students. Okay, how to cover the syllabus. So is it possible to cover the 2024 GATE syllabus timely and entirely? Yes, if it is possible, what should be that correct time? How much can you cover in the remaining time? All your doubts, a very important parameter, because syllabus management is one of the biggest, thing that will decide where your success is going. Okay, where your success is going. Done. Ananda, do you want to ask cos of xn? Cos of xn. Give me the IO relation. Okay. Yes, Ghosh, I told you, na. We will cover all chapter of Openham. We will cover all chapter. Today is basics. Wednesday, LTI system. Okay. Bhai, I'll just give you the hint. Okay, like today. Okay, today we have the basics wala chapter. Next class will be Wednesday. We will have LTI system chapter, everything, convolution and all those things. Okay, Friday I will run this but MWF. Okay, ठीक है. Friday I think Fourier series आ जाएगा, continuous time Fourier series as per the sequence of chapters of Openham. देख लेते ना, देख लेते हैं. This is the Openham. So what is going to be the Friday's class? Yeah, chapter 3, Fourier series representation of periodic signals, continuous domain में. Okay, next chapter will be Fourier transform. Next DTFT. Next will be sampling भी cover करेंगे. Okay, next Laplace transform. Next Z transform. Everything relevant to GATE. Okay, 1 or 2 chapters are not that relevant, but everything directly with the GATE syllabus ये पूरा cover हो जाएगा. ठीक है, चलो done. X of 3n cos नहीं है क्या अनंता? Write down the question once again, अनंता. Write down once again. चलो next question 1.27. Okay, so please note down this. Okay, next class again important, everything with respect to convolution theory. Friday Fourier series. Okay, next Monday Fourier transform, the very important. चलिए 1.27 Okay, in this chapter, we introduced a number of general properties of system. In particular, a system may be memoryless, time invariant, linear, causal, stable. Determine which of these properties hold and which do not hold for each of the continuous time systems. Justify your answers. In each example, okay, YT denotes the output and XT is the system input. Okay, I'm telling you now, in the book, okay, in the book, it will be looking like a conventional question. Okay, but you know how to deal with it as a gate level question. Okay, and I am assuming, be very clear, that this is the open-hem questions. Dekho, whether it is standard book question or any question, when do you go for a question? When you are done with the theory, when you are done with the concept, when you are done with the concept. Clear, everybody? When will you go for the theory? When you are done with the concept. Okay, so if I start telling you each and every concept now, how to check linearity, how to check time invariance, I don't know how much time will go away. So my focus is questions, and of course questions. आप भी किसी book के question पे कब जाओगे? It is the questions of this book. When will you go? Once you complete the chapter. Okay, now whether you have completed a chapter from this book or from your regular classes or from YouTube, whatever, that is totally up to you. Okay, that is totally up to you. तो चलिए आते हैं यहाँ पे हम. Okay, now you know there are several tricks to identify especially linearity and time invariance, because if every problem you apply linearity time variance, that is going to be time consuming. That is going to be time consuming. That is going to be time consuming. ठीक है? चलो. Discrete domain में no. Discrete domain na no Ananta. Okay, simple reason is what is x3n? You are shrinking the signal. Invertibility कैसे होगी? Okay, x3n you have shrink the input. Okay, when you shrink the input, okay, some of the samples are lost. That is the problem with discrete time compression. Na? In the discrete time expansion, zero padding come. In the discrete time compression, some of the values are lost. Okay, so when you want to go back to the original, okay, so that lost values are lost. That is a loss of information. That is why the answer will be non-invertible by this logic. Okay. By this logic, Ananta, it will be non-invertible. चलिए आ जाते guys. First one, tell me x of t minus 2 plus x of 2 minus t. आ जाते हैं A वाला. Okay. Y of t is equal to x of t minus 2 plus x of 2 minus t. Tell me, dear. Tell me first one, simple one. Simple one. ठीक है. हाँ जी, yes, sorry for the interruption. चलिए आ जाते हैं. Okay, so xt minus 2 plus x2 minus t. xt minus 2 plus x of 2 minus t. So guys, okay, very clearly, okay, if you take y0 only ना, if you take y0 only, नहीं, 0 नहीं लेते. हाँ, 0 ले लो, कुछ भी ले लो. Okay, because of this factor actually, you are able to clearly see कि memory तो है t minus 2, that is going to take you towards the past. Okay, memory is there. Okay, memory is required. X of 2 minus t, causal or non-causal? Okay, suppose you check y0. Okay, so that is x minus 2. Okay, plus x of 2. Okay, so this is past. Past means again memory. Okay, but this is future. And whenever the output depends on future value of the input, because present मेरा 0 है, okay, it is non-causal. It is non-causal. It is non-causal. Acha, y is directly x power 1 function. Okay. I'm not going to derive the linearity test. I will use the results of linearity. Okay, go through my lectures if you want on the app or on the YouTube if you want. Y is x power 1. Okay, y is x power 1. Okay, it's a direct function. Whenever y is a function of x power 1 without any DC component, it is always linear. It is always linear. Okay, so linearity to ensured hai yahan pe. Time invariance. Whenever there is a scaling involved, listen to the important points. Okay, scaling or folding hai. Whenever there is scaling or whenever there is folding, okay, time scaling की बात कर रहा हूँ, not amplitude. Whenever there is time scaling or time folding, system can never be time invariant, it is time variant. Okay, so because of this the system is time variant. Are you getting it? Because of this the system is gonna be time variant. Okay, it can never be time invariant. Okay, stability. Now stability, BIBO stability, bounded input should produce a bounded output. Finite input should produce a finite output. Now please have a look into this. Okay. Have a look into this. What is going to happen now? If input is finite for all values of time, okay, input is finite for all values of time, okay, so both the parts are finite and finite plus finite. Okay. Finite. Finite plus finite is gonna be finite, so it's BIBO stable. It's BIBO stable. Correct, Ananta. So what are the operations that is satisfying here out of this? Okay, memoryless, no. Time invariance, no. Linearity, yes. Okay, causality, no. Stability, yes. Linear and stable. I'll just keep writing that abbreviation. Okay, let this be memoryless, let this is time invariant, this is linear, this is causal, this is stable. Okay, dear, come on quickly to the next one. Cos of 3t_xt. Let's go to the next one, that is the cos of 3t_xt. Option number B, cos of 3t_xt. Cos of 3t_xt. Hanji, tell me. Okay, second one, cos 3t_xt. Cos 3t_xt. Okay, now see, it is a separate function of time, dear. Whenever you have a separate function of time, system will always be time variant. Whenever xt multiplied by any separate function of time, okay, it is always time variant. Okay, but what is the relation of y with x? It is x power 1, na? Ye to ek separate function. It is not a time, it is not an input function. It is a time function. Okay, so it is like y depends on x power 1. So linearity is still ensured. Linearity is still ensured. ठीक है. Memoryless या not? Okay, see guys, only and only present. Okay, to calculate the output at t, the input value directly is required at t only, no transformation on t. So it is only present. That means memoryless bhi hai, at the same time it is causal also. Okay, it is causal also. It is memoryless and causal. Okay, if input is finite, okay, y will be cos. Cos is also finite multiplied by finite. See, stability is always tested. Stability is always tested by taking finite input. You don't take infinite input. Okay, stability is always tested by taking finite input. Okay, so directly I am assuming input finite, so output is also finite, so stability is ensured. Okay, तो क्या क्या निकाल लिया यहाँ पे? In the second question, you have memoryless, yes. Time invariance is not there. Okay, but linearity, causality, stability, 4 properties are there. 4 properties are there. Okay, you just keep telling me the property which is there. जो नहीं है, forget. Whatever the properties are there, I'll just keep writing it. Third, integral minus infinity से 2t, again scaling. Okay, if it is minus infinity से t, story will be different. Okay, so yt, integral x tau. Integration is a linear operator. Integral f plus g. Integral f plus g. Integral f plus integral g. Integral f plus integral g. Okay, तो c पे आ जाएंगे अगर हम. If I want to come to the c1, y of t is integral minus infinity से 2t x tau d tau. Okay, it is linear. This one is known as linear. Okay, this one is known as linear. Okay, but 2t is going to make it as time variant. If it was, let me repeat, if it is minus infinity say t, then it will be non-linear, then it will be time invariant also. Okay, 2t, that scaling is going to make it time invariant. Okay, time invariant. Okay, what else? Acha, this 2t only says that ki system memory hai. Okay, I mean depends. If you want to take negative value, suppose आपने लिया y -1, so it is integral minus infinity से 2. Okay, but at the same time if you take y1, it is integral minus infinity से 2. Okay, so there can be future also. You are calculating output at 1, but you need the input values up to the 2. You are integrating the input now. Okay, at the same time minus 2 is past. If you are calculating at minus 1, minus 2 is past. Past matlab memory. So it is memoryless? No. It is causal? No. So it has memory and it is non-causal. It is non-causal. Okay. Kya bacha? Stability. Is it stable? Is it stable? Okay. Let x tau equal to 1. Bounded input. Now you want finite input. Take a very simple value. X tau equal to 1. Let x tau equal to 1 for all tau. Okay. So what is the value of yt? What is the value of yt? Integral minus infinity से 2t 1 d tau. 1 d tau. Okay, now d tau integral is tau. Lower limit minus infinity, upper limit 2t, and this is going to be 2t minus minus plus infinity unbounded. It is unbounded, dear. It is unbounded. It is unbounded. Output turns to be unbounded. So it is US, unstable. It is unstable. तो क्या क्या prove हो गया? For the C part, what all is proved? Okay, for the C part, what all is proved? Let us check for the C part क्या क्या prove हुआ है. कहाँ है C part? हाँ ये रहा. Okay, memoryless, no. Time invariance, no. Linearity, yes. Causality, no. Stability, no. Only linear. If I'm not wrong, it is only linear. Correct. Okay, if it is only linear. It is only linear. But at the same time, if I do a change, if I do a small change, ये हो गया C. Okay, at the same time, if I just do a small change, if it is minus infinity से t x tau d tau, if it is minus infinity से t x tau d tau, okay, right, then this will be linear. Anyways, this is linear. Then it will be time invariant also. It will be time invariant also. You can try by the time invariance tool. Na? Time shift in the input produces similar time shift in the output. So ये time invariant होगा. Memories तो anyways है because you are integrating from minus infinity से t. Okay. Other than that, it will remain to be causal also. But you are calculating output at t. Okay. You need the integration up to t, na? Not beyond t. You need up to t. Okay. So causal भी रहेगा. Stable will still not be there. Okay, because of the similar calculation. Memoryless nahi hai. So these three will be there. I mean, right now it is only linear, but if it is minus infinity से t, remember, then causal and time invariance will be added. Linearity is still there. So you should know the difference. You should know the difference. अगर ऐसा नहीं कि ये आंसर हर बार मार्क कर दिया minus infinity से t, so it will be causal and time invariant also. ठीक है जी, done है. चलो, what is the d part? Come on, what is the d part? Yt is 0 for t less than 0. Yt is xt plus xt minus 2 for t greater than 0. Whenever, guys, what do? Whenever you want a signal to exist only for right side, t greater than equal to 0. T greater than equal to 0. What do you do? When you want the signal only to exist for the right side, okay, only for the right side. So I have xt plus xt minus 2, t greater than equal to 0. I will write this as x of t plus the x of t minus 2, and that is whole multiplied by ut. Just multiply by ut. Okay, right? Integration 1 to 2t, no, then also unstable. Why? Ananta, then also unstable, because ultimately it will be a function of time. Okay, so see, input is finite for all values of time, na? Output should also be finite for all values of time. But if the time keeps on increasing, output will go in the increasing unbounded zone. ठीक है? Unbounded zone. So then also unstable. Integral will be unstable. Okay, integral will be unstable. Done है. आ जाते हैं. हाँ. So now this is multiplied by ut. Clear? This is multiplied by ut. Now ut the separate function of time है. Okay, separate function of time, dear. Okay, separate function of time. Okay, as I told you here, whenever there is a separate function of time, the system will be time variant. It cannot be invariant. So ये time variant. But relation between input and output, y actually depends on x power 1. ये तो separate time का function है. The relation between y and x is y is x power 1. This is also x power 1. Okay, right. So y is x power 1. So that is linear. Okay, this is clearly t minus 2. It is going towards memory. It is using the past value. Okay, but only present and past. Okay, only present and past, no future, so it will be causal. Okay, it will be causal. 4 things are checked. Okay, stability check karenge. Okay, yt, input is finite for all times, so finite plus finite multiplied by ut. Ut भी finite है. Ut is anyways 1 for t greater than 0, otherwise तो 0 है. तो output is always finite. If input is always finite, output is always finite, तो system is stable also. System is stable also. तो आ जाते हैं, it is stable also. Okay, so D part is also done. D part is also done. So what all is there in the D part, dear? What all is there? Linear, yes. Okay, causal, yes. Time invariance नहीं था. Stable, yes. And memoryless, no. Linear, causal, stable. Linear, causal, stable. Okay, that should be the D answer. Okay, E. Now, E में देखोगे, yt is 0 for xt less than 0. Yt is xt plus xt minus 2 for xt greater than 0. Previous question condition is on time. Here the condition is on xt only. Now what I did for the previous question? What I did, when I want t greater than equal to 0, when I want the t greater than equal to 0, I multiplied by the ut. I multiplied by the ut. Okay, now I want xt greater than equal to 0. I want xt greater than equal to 0. So I will multiply by u of xt. Understand the logic. I will multiply by u of xt. E part pe aate. I will multiply by the u of xt. Okay. I will multiply by the u of xt. So xt plus x of t minus 2 whole multiplied by u of xt. Whole multiplied by the u of xt. Done hai? Whole multiplied by what? By the u of xt. ठीक है, ये u of xt से multiply होगा. ठीक है, u of xt, not ut, u of xt रखेंगे घोष. Okay, so that whenever automatically you see na, whenever xt greater than 0, whenever argument positive, ut will give you 1, but whenever xt less than 0, ut will give you 0 na. Okay, and something into 0 you will get 0. That is what you want. For xt less than 0 you want 0. Okay, अब बताइए, अब बताइए. Okay, yt. Now relation between input and output. This part is linear, but u of xt non-linear. Y is directly x power 1 function. That is only linear. I am telling you now, we will not prove linearity right now. उसके लिए आप मेरे बाकी videos देखो. But we will use the direct results because the output depends on u of input, non-linear. Output should only depend on x power 1. But is there any separate function of time? This is input function, this is input, and this is also input. It's not ut, it is u of xt. Any separate function of time? Okay, no. So देखो यहाँ पे there is no separate function of time. There is no separate function of time. Okay, there is no scaling, there is no folding. ना scaling दिख रही है, ना folding दिख रही है. Okay, so seems like system is time invariant. This one is time invariant. ठीक है. Hello aids. This one is time invariant. Okay, rest you all know. Okay, ये वाला condition तो है ही. What is this condition? Okay, this is past. Okay, right. तो ये memory था, यहाँ पे भी memory है. Okay, present and past. Okay, past बोले तो memory, but only present and past, no future. So it is causal. It is causal. It is requiring memory. Okay, 4 properties are checked. Stability. Okay, stability. ठीक है. Tell me stability. I'm good. It's okay. Tell me about stability. So finite plus finite, na? Finite plus finite into unit step will also give finite. This is finite, so system is stable. If the input is finite, output is also finite. Okay, stable भी है. So what all is satisfied by this part, E part? So आप देख रहे हो यहाँ पे lots of good practice you are getting. Lots of good practice you are getting. Okay, so for E part, let me write down the answer. Linear? No, it was non-linear. Time invariance? Yes. Causality? Yes. स्टेबिलिटी यस, मेमोरी लेस नो. ठीक है, ओके डन. F yt is equal to xt by 3. Yt is equal to xt by 3. Now can we say, after learning these many things, can we say it directly? Can we say this directly? Y is a x power 1 function. Y is a x power 1 function. Okay, right. Yes, quality question goes. Okay, y is equal to x power 1 linear. Time scaling, time invariant नहीं होगा. Time scaling is there ना x80, so it will be time variant. Okay, causal or non-causal, decide. T and t by 3, definitely past will be there. If you take x y1, x of 1 by 3, so memory is also not there. Memory is required. Stability, yes. But if input is always finite, the output directly depends on input. Na? If x is finite, y is also equal to x, y is also finite. If input is always finite, output is also always finite. Stability hai. Causality, can there be future? Can there be future? Y minus 3 negative. See, when you think about especially scaling questions and all, think about negative time also. Okay, y minus 3 is x minus 1. So if you are calculating at minus 3, minus 1 तो बाद में आएगा ना, negative time, minus 3 minus 2 minus 1. So you are calculating in minus 3, but minus 1 is future. No, Ananta, it is not causal. That's what I'm telling. This one is future. बस एक एग्जाम्पल लिखना था, वो मैंने समझा दिया. Rest it is understood, I think. It is non-causal. Think about not only positive but negative also. If you think about positive time, definitely only past values are there. But if you think negative time, the future values are also involved. ठीक है जी? ठीक है जी? Done है? Okay, तो F part is also done. Okay, now G part, differentiation. Guys, one part as a homework. Integration वाला main था, वो समझा दिया. F part will be a homework for you. Sorry, E, F, G, G part. Okay, G part, ये अलग से लिख देता हूँ if it is not visible. Okay, simple differentiator system. Differentiator d by dt of xt. Okay, that is a d by dt of xt. Take it as a homework. थोड़ा efforts आप भी डालिए. Okay, थोड़ा efforts आप भी डालिए. Okay जी, done. Let's go to the next question then. Let's go to the next question. Oh my God, time is approached 10:30. चलो करते, no problem. If you are all okay, I'm also okay. Let's move ahead. 1.2 है. Now guys, let's not spend much time here. There are some similar parts, okay, which I will give you as homework. कुछ ही parts यहाँ पे pick up करेंगे. Okay, so out of this in discrete time, okay, because the rules to calculate linearity, time invariance, causality, stability, everything remains to be same. Okay, so what all will be the homework? A will be the homework. Okay, time folding, similar case है. Okay, x n minus 2x, like xt minus 2, xt minus 8 ना, similar variety है. Okay, similar variety है तो B also homework. Okay, C also similar variety. Okay, DB, only thing is you have to expand the formula. What is the even part formula? X t plus x minus t whole divided by 2, same formula. Okay, same formula. Okay, तो DB homework ले लीजिए. Okay, ये E और F को थोड़ा डिस्कस करते हैं and G also will be homework for you. G also is homework for you. Okay, so out of discrete, let me give the repeated or similar parts. Okay, if you have followed the previous one, if 1.27 question is understood, then you are able to solve those homeworks. Then you are able to solve those homeworks. Okay, थोड़ा सा बस ये जो split होता है ना, where the students are confused when the definition is split. Okay, that we shall understand. E and F को understand करते हैं. Okay, E and F. So what is the E? Let us rewrite it. E is given by what? It is x of n, but for n greater than equal to 1 only. It is 0 if n is equal to 0. Okay, it is x of n plus 1 left shifted if n less than equal to minus 1. हाँ जी. Okay. Non-causal, Ananta. Some of the books will say causal, but it is actually non-causal. It will be actually non-causal. Okay? Because see, first principle says was, okay, f of x plus h minus f of x. Hey, what is the differentiation? F of x plus h minus f of x. Okay, you're differentiating with time, na? The x of t plus right hand derivative कैसे निकालोगे? X of t plus h minus xt. So that will involve some future value. that will involve some future element. Okay, ठीक है, because of that. ठीक है अनंता, चलिए. Now guys, how to write down this function? So what is the yn? Yn can be written as xn for n greater than equal to 1. Okay, n greater than equal to 1. So why not multiply by un minus 1? Like for n greater than equal to 0, we are taking un always, na? So for n greater than equal to 1, let us take the un minus 1. So yn is equal to xn into un minus 1. xn into un minus 1, ठीक है? yn is equal to xn into u of n minus 1. ठीक है, ये हो गया. ओके, xn into u of n minus 1. और बोलिए. ओके, it is 0 at n equal to 0 plus x of n plus 1. For n greater than equal to 1, what do we write? u minus n minus 1. चेक कर लीजिए ना भाई. When is the unit step existing? When the argument is positive. भाई, when the argument is positive. Okay, so this will exist for n minus 1 greater than equal to 0, that is n greater than equal to 1. Satisfied. This unit step will exist if minus n minus 1 greater than equal to 0, so n less than equal to minus 1. Satisfied. So that means, dear, pay attention, if n is equal to 1, 2, 3 greater than equal to 1, ये वाला exist करेगा, but this one will be 0. If this one is 0, yn is equal to xn only. Clear? Okay, for any value n less than equal to minus 1, any value of n less than equal to minus 1, what will happen? Okay, this one will exist. Okay, but less than equal to minus 1, this wala 0. Okay, this will go for greater than 1. So this wala 0. So only what is left is xn plus 1. This is what you want. Smart way of writing the function. और अगर आपने 0 लिया, what is y0? Okay, तो यहाँ पे आएगा u minus 1, something into u minus 1, something into u minus 1. If you put n 0. But what is the value of unit step at minus 1? Does not exist, na? 0. Only n greater than equal to 0, na? Time should be positive. So y0 will be 0. तो ये भी satisfy हो जाएगा. Okay, so that's what it is. Okay, so this is the way of writing this function. And now, please tell me, okay, y, okay, is a function of x power 1 first of all. It is a function of x power 1 eventually. Okay, but there is a separate function of time. Okay, there is what? There is a separate function of time. Okay, because of the separate function of time, it is going to be time variant. Okay, but linearity is still ensured. Y is x power 1 only at the end. Okay, linearity, okay, can be ensured. Okay, linearity will be ensured. Okay, now, next is what? Okay, if input is finite, okay, if input is finite, okay, this is finite. If input is finite or all values of time, xn is also finite, xn plus 1 is also finite. So finite plus finite, stable. Just let's orally solve it up. Okay, causal or not? Okay, causal or not, this is definitely future. This is definitely future, xn plus 1. Okay, yn, somehow xn plus 1 is coming, that is future. Okay, that is the future. Okay, so non-causal. Okay, time variant पहले ही बोल दिया था. What else is left? Memory. Memoryless means static system, only present. Okay, अगर non-causal है तो memory तो हो ही गया. Okay, so what is the answer? It is actually only linear and stable. Okay, we need to specify that property ना. तो E is only linear and stable. Linear and stable. Okay, next पे आ जाएंगे F. Next पे आ जाएंगे F. Okay, now xn for n greater than equal to 1. It is again xn for n less than equal to minus 1. Right? Okay, right. X, yn equal, yn is just xn only for all values of time greater than equal to 1, less than equal to minus 1, except origin. इसका ये भी मतलब है. Okay, let us solve the f part now, dear. Let us solve the f part now. So what is the f part? Yn is equal to xn for n greater than equal to 1, 0 for n equal to 0, again xn for n less than equal to minus 1. So I can say that yn is equal to what? Yn is always equal to xn except one point. Yn equal to xn, okay, for any value of n not equal to 0. But if n equal to 0, it is 0. थोड़ा और simple कर देते हैं ना. Why to write 3 parts? Yn is xn for n not equal to 0. Okay, right? No, yt, DC component, DC term, non-linear. Everybody, Vikram and everybody listen, y is x power 1 only, then it is linear. Okay, xt plus a DC component, non-linear. Okay, plus a constant component. Okay, but like the types we have solved, xt plus xt minus 2, both are xx, then it is linear. Okay, because it's like, you can break, it's like addition of two linear systems. Okay, if two linear systems are added, it will be linear only. That is the logic. Okay, but xt plus a constant, that constant will be non-linear. ठीक है जी, चलिए आ जाते हैं इस पे. So this is the way of writing yn. Now let's make it even more simple. Okay, somehow n equal to 0 पे I have to eliminate, okay, the signal. Yn is equal to xn except origin. How to get the origin value of xn? If you want to get the origin, if you want to get any sample of xn, you can multiply with the unit impulse. So suppose xn into delta n. Okay, now what is xn into delta n? Dhyan dena. Dear, what is xn delta n? Impulse property. It is x0 delta n. It is known as x0 delta n. Okay, x0 delta n will give you, okay, delta n is only at origin with the amplitude x0. Okay, so now I want to subtract these two. So see, automatically what will happen? If n is not equal to 0, yn is equal to xn minus 0, because for any value of time not equal to 0, impulse will not exist. No, impulse, this delta n is only at origin. Okay, so delta n will be 0, yn equal to xn. But if n is equal to 0, pay attention. If n equal to 0, yn is equal to x0. Minus n का 0 रख रहे हैं ना, n को 0 रख रहे हैं, तो what is y0? x0 minus x0 delta 0. What is delta 0? Discrete time unit impulse has finite magnitude. Okay, so this is also 1 minus 1, 0. You get your answer. That is why I am discussing the E and F parts. You have to understand how to write the functions before solving it. Okay, so what is that F part now? Okay, so I can say that yn is now equal to xn minus xn delta n. उसमें से भी xn को common लिया तो it is 1 minus delta n. xn into 1 minus delta n. Now very quick. Linear? Yes. Y is x power 1 eventually. Okay, depends on x power 1. This is a separate function of time. But whenever there is a separate function of time, the system will be time variant. Any separate function of time multiplied, the system is time variant. That's what we have been discussing. Okay, causal, देखो ना, it is only present. It is only and only the present value of input. So yes, it is memoryless also, causal also. Only present. Stable? Arey, yn is directly xn, na? Yn is either 0 or xn, but for stability we check with the finite input. So finite input, finite output, कोई doubt ही नहीं है, भाई directly follow कर रहा है ना. Okay, so it is stable also. Okay, so only thing it is not following is time variance. So let me write down the answer there. For the F part, the answer will be memoryless, okay, linear, causal, stable. Time invariance is lost. Only time invariance is lost. Done hai ji? Okay, rest all for discrete time homework because it is similar to the continuous time case. Continuous time हमने already solve किया है. ठीक है जी, चलते हैं next question की तरफ. Okay, let's go ahead to the next question, dear. 1.41. This was under the advanced problem section. Okay. Consider a system with the input xn, output yn related by yn is equal to xn, gn plus gn minus 1. Okay, gn plus gn minus 1. Okay, input xn, output yn. Okay, yn is equal to xn into gn plus gn minus 1. Okay, if gn equal to 1 for all n, show that the s is time invariant. If gn equal to n, show that s is not time invariant. Show क्या? Let us just okay solve it up. Okay, don't need to solve it as conventional problem. Okay. Right, so if gn equal to 1 for all n, first case, why, what is the first case? Yn is equal to xn, okay, gn for whatever may be the value of n, gn is always 1, na? So even if you right shift it, that is also 1 only. then also it remains to be 1, because for all time it is flat 1. Okay, so what is the relation of the first part here? Okay, what is the relation of the first part? Yn is equal to 2xn, which is clearly time invariant. By how the system becomes time variant? Any separate function of time? Yes, यहाँ से MSQ बन सकता है. Okay, a separate function of time. Okay, scaling, folding, all this will make time variance, na? So it is time invariant only. Correct. तो MSQ कैसे बनेगा यहाँ से? Okay, for which of the Gn the system will be time invariant या time variant? Like that MSQ will be there. Okay. Now let us come to the B option. Okay, Gn equal to n. Gn equal to n. So what will be Yn? It is equal to the xn is multiplied by Gn. So Gn is equal to the n. Gn is n. So what is Gn minus 1? If Gn is n, Gn minus 1 is n minus 1. Gn minus 1 is n minus 1. So what is the value of Yn? Okay, n plus n minus 1. That is known as the 2n minus 1. That is known as the 2n minus 1 xn. That is known as the 2n minus 1 xn. 2n minus 1 into the xn. Okay, Yn is 2n minus 1 into the xn. ठीक है जी? Okay, now there is a separate function of time, and separate function of time means time variance. Separate function of time, time variance. It cannot be time invariant. और यही proof करना था. Okay, see, we are not proving by conventional method. I told you, na? Okay. Yes, if you still dedicate Chirag around, say 8 to 10 hours, it is possible to cover maximum. Okay, maximum. Okay, some 10% unimportant topics you can skip. That's what you can do. Okay. चलो, how के लिए बाद में पूछना. You can ask me later on personally Telegram पे. Right now lots of questions are left and already it's 10:45. Okay, so I think open questions will take time, but I think students, if you are ready, let's extend the time also, no problem. Okay, I thought 1.5 hours, but it is already 10:40. Gn is 1 plus minus 1 power n. तो C को solve करेंगे आप. Okay, C को solve करेंगे. Okay. तो what is the Yn? Yn is equal to the xn. Yn is equal to the xn into Gn. What is the Gn? Okay, what is the Gn? Okay, 1 plus minus 1 power n. Okay, plus Gn minus 1. Next is Gn minus 1. Okay, Gn minus 1. So 1 plus minus 1 की power n minus 1. 1 plus minus 1 की power n minus 1. Okay, ठीक है. चलिए आ जाते हैं. तो what should be the value of the Yn? The value of the Yn is equal to the xn. Okay, ये 1 और 1 तो add हो गया, that is 2. Okay, plus minus 1 power n, plus minus 1 power n. अच्छा, minus 1 power minus 1 will be negative. Okay, so we can call it as minus of minus 1 power n. Okay, okay, so this part, okay, the n part is cancelled actually, and it comes to the first case only actually. Okay, the final equation is just like the first case. Okay, it will be equal to xn multiplied by 2. Yn is equal to 2xn. It is again time invariant. Okay, it is time invariant. Yes, we had to show that it was time invariant. Clear? It is time invariant. But we are not showing by any conventional method. We are showing by the gate stuff. Okay, gate type of methods. जो gate exam hall में करना है. Okay, जो ESC prelims में करना है. Conventional is a later stage. Okay, even all the questions we solved for linearity, time invariance, we have solved by observation. None of the conventional approach I have applied. But if you want to learn the basic techniques, you have to watch. You can watch some of my previous videos onto it. Okay. Okay. I think I have a video taken on LTI system, yeah, maybe separately on linearity or time invariance. You can search. You can search onto that. मिल जाएगा आपको YouTube पे. ठीक है, done है जी. Okay, done है. ठीक है, so this one is done. Next one, 1.32. Okay, चलो ये तो simple है. The next part specially is important. The next part specially is important. Tell me. Okay, the next part specially is important. Tell me. हाँ जी. Let xt be a continuous time signal. Okay, what do you know about periodicity? Scaling, continuous time domain is scaling or compression doesn't affect the periodicity. Okay, if xt is periodic, y1t is periodic. Okay, what is y1t? Compression. Okay, this one is compressed. X of t by 2 expanded. Okay, expanded. Okay, right. And let me tell you the time period results also. What is the time period for x2t? Okay, the new time period will be given by Because it is compressed, now the time period will also be compressed. Okay, this one is expanded, so time period will also be expanded. That will become 2t. Okay, remember for xat, the time period will be t by a, will be t by mod a, will be t by mod a. ये ध्यान रखना. In continuous time domain, scaling compression expression will not affect the periodicity. Okay, so here, okay, which of the statements are true? Okay, all are true. Okay, if x1t is periodic, y1t will be periodic, y2t will be periodic, and vice versa is also true. If y1t is periodic, okay, right, if a compressed waveform is periodic, that is only possible if the original waveform is periodic. ये तो सारे true हैं. Now dear, this can be a MSQ question. Be ready. This can be a MSQ question also. 4 options. Which of them is correct? Okay. So actually I don't want to discuss much this because this continuous. What I actually want to discuss उस पे आते हैं. I want to discuss this next one. This one is tricky. This one is conceptual. 1.33. Discrete time में कहानी change होगी. y1n is x2n. Same type of thing, but I am taking in discrete time. y1n is x2n. y2n is x of n by 2. X of n by 2. Okay. So of course, if it is x of n by 2, n can only be even, because अगर n को लिया odd like 1 by 2 or 3 by 2, it will automatically be 0 ना. It will automatically be 0. Why? Because discrete time signal is only defined for integral values of time. Integral values of time. Okay. Integral values of time. Okay. ठीक है. Yes, in continuous domain, Vikram. In the continuous domain. Tell me. Actually not nt, na? You are talking about period. The frequency becomes nf like that, na? Like cos t. Okay, 1 plus cos 2t by 2. The frequency doubles there. So time period is half, Vikram. Just have a check. Just have a check. Dear, bata dijiye iska. Okay, to answer this, I'll draw one waveform and give you the result. Okay, I'll give you the result. Just a okay, chalo. Now let's check it out. Let's check it out. Okay, the signals y1n and y2n respectively, in some sense, the speeded up and slowed down. Okay, we know what is the meaning of compression and expansion. Okay, उस पे नहीं जाते हैं. I'll just take an example to explain you this. Okay, and let's consider a particular example here. Let us consider a signal xn versus n. Okay, of course we have to consider that xn is a periodic signal. Okay, we should be considering that there is a xn which is the periodic signal. Okay, let's say this is a periodic signal that I am trying to take. Okay, have a look into this. Have a look into this. Okay. Yeah, ये data जो loss हुआ है ना, because of that only the problem will come. Okay, so now this is xn. Okay, this is known as xn. What I will do is with this xn, okay, xn, this is periodic. xn has to be periodic, and what is the period? Period I have taken to be 2. Okay, देखो ना, this repeats after 2. This amplitude 2 repeats after every 2 units of time, and then similarly -1 also keeps repeating. Okay, now with respect to this, what we are supposed to do is, with respect to this, let us draw x2n and x of n by 2. दोनों यहाँ पे प्लॉट करेंगे. What is y1n is x of 2n, is x of 2n. Okay, okay, and then I will draw and what is the y2n? That is x of n by 2 expansion. Okay, तो आ जाते हैं, let's do it one by one. Okay, compression means divide all values of time by 2. तो origin 0 by 2 will be 0. Origin remains to be at origin, उसमें कोई change नहीं है. Okay, but now the difference that is going to come in discrete time, dear, is okay, when you compress in time, okay, you get 1 by 2. What is 1 by 2? What is 1 by 2? It's non-integer, and because it's non-integer, it cannot be considered the discrete time signal. Okay, whether it is xn या y1n या y2n, discrete time signal can only be defined for integral time. So this will go away actually. This will be lost. Directly you will take the value at 2. 2 divided by 2 will be 1. Okay, 2 divided by 2 will be 1. Okay, so the same value repeats, but at 1. Okay, now next 3 by 2 cannot be taken, lost. 4 by 2, 2. 4 by 2, 2. Okay, and etc. Okay, etc. Okay, now pay attention, please. Pay attention. I can say that if xn is periodic, very clearly y1n is periodic. Wait, it is periodic with the period 1. Okay, this remains to be periodic with the period 1. Okay, with the period 1. Okay, with the period 1. Okay, integral time means time can only be integer in discrete time, na? 0, 1, 2, minus 1, minus 2, 1.5, 1.7. That is not a valid time in discrete domain, Kumar. Okay, that is what is integral time. ठीक है जी, चलिए. So clearly this is periodic. I have drawn the waveform, I have compressed this, I have got the periodic. So I can say that y1n, that is the compressed version, x2n is periodic. With period of 1. Okay, xn is periodic with period n. So in general, if that is n, so this will be periodic with the period n by 2. Clear? Okay. What about y2n? वो learn करते हैं अभी, ठीक है? But next statement, dear. Okay, next statement, please note that if y1n is periodic, please, important point. If y1n is periodic, okay, then what about xn? What about xn? Tell me. अब देखो, ये सबसे इंपॉर्टेंट और कॉन्सेप्चुअल पार्ट है यहां पे. सपोज दिस सिग्नल इज पीरियोडिक. ओके, कैन यू से दैट द xn is also periodic? Right now we don't know xn, we only know this y1n, which is the compressed version of xn. Now pay attention, because it is compressed version, some samples of the original signals have been lost. Here they don't appear. Some samples, this have been lost actually, and then they don't appear. You actually know it, but suppose you only know y1n. Okay, then you don't know what samples are lost. Okay, suppose we go back reverse. Listen to me. Suppose we go back reverse, and okay, this value was -1. Suppose this value was -2. This value was suppose randomly 4. Now can you tell that this is periodic? Now can this be periodic? Although if you compress it again, alternate values are 2. If you compress it, you get the periodic signal. Listen to each and every word. Orally I am explaining. This will be periodic because alternate samples are 1. Okay, alternate samples are 1, but other alternate samples are random, -1, -2, +4. So this signal is actually aperiodic, but still the compressed version is periodic. Are you getting it? So that means if you know a compressed version that has been obtained by loss of data, so whatever is that original data, okay, may be showing periodic pattern, may not be showing periodic pattern. पूरा कॉन्सेप्ट में घुसना पड़ता है. ओके, ठीक है? यस राहुल. सो दैट्स व्हाट आई कैन से इज ए y1n इज पीरियोडिक, xn may or may not be periodic. Okay, xn may or may not be periodic. xn may or may not be periodic. It may or may not be periodic. ध्यान रखना, ठीक है? It may or it may be. I don't know what are the missing samples. Okay, so देखो, if x1n is periodic, Okay, y1n is periodic, y2n is periodic. But if y1n is periodic, x2, xn is periodic? Maybe, but that maybe is never a conclusion. Okay, maybe is never a conclusion. So I will call it as false actually. इसने बोल दिया periodic. Okay, so I will call it as false. This statement is not correct, na? Now D, y2n is periodic. Now y2n, I have to draw the y2n quickly. Y2n means, oh sorry, x of n by 2. y2n is x of n by 2. That is expansion. Okay, expand. Expand. तो origin remains at origin only. उसमें कोई doubt नहीं है अभी भी. Okay, expand means multiply the time by 2. तो 0 into 2 will be 0. Okay, now 1 into 2. Listen to me. 1 into 2 expansion. 1 into 2 will be 2. So directly you will get the next sample at 2. Directly you will get the next sample at 2. Okay, at the time 2. So what will you take at the time 1? You have to define for all integral values of time. Na? So what will you take at the time 1? Nothing is available. That means it is 0 value. That means it is 0 value. This is known as 0 padding. Okay, when a discrete signal is expanded, there will be 0 padding. Okay, now similarly the value at 2, that will go to the 4. That will actually reach the time 4. Okay, this will be the time 4. Okay, so what is there at 3? Again missing sample. So that is 0. Okay, then there will directly be minus 6 actually. So what is there at the 5? That will be 0 again. Clear? That will be the 0 again. That will be the 0 again. बोलिए, fantastic, lovely है ना? Okay, so definitely this is periodic. Right. 2 0 minus 1 0, 2 0 minus 1 0, etc. This is periodic. Okay, it is periodic. So if xn is periodic, okay, y2n, okay, that is x of n by 2, that is the expanded form, that is also periodic. Result है मेरे पास. That is also periodic. And with what period? With period also expanding. With period 2n. See, what is the period now? What is the period now? It is 0 to 4, 4 units. After 4 units, it is a repetition. Okay. Okay. Now, next is what? Next is what? Next is if y2n is periodic, then what about xn? If y2n is periodic, okay, so what about xn? What about xn? Yes, so there is no loss of data here. There is only 0 padding here. Okay, if this is periodic, that means when you go back to the original signal, we know that it will be coming here. It will be coming here. Only zeros will be lost. When you go back to that signal, na? When you go back to that signal, again from the expanded to the regular form, this will be gone, this will be gone, this will be gone. But actually periodicity is still there. 2 minus 1, 2, minus 1, 2, minus 1, 2, minus 1, 2, minus 1, 2. After every 2 times it is repeating. Okay, so here there is no problem. Here there is no problem. Only these zeros will be lost, but rest values are also repeated in nature. Na? 2 minus 1, 2 minus 1, etc. Okay, so I can say that if y2n is periodic, y2n is periodic, xn is also periodic. यहाँ पे कोई doubt नहीं है. Okay, so only one of the statement goes false. Option number D is also true. And again I am repeating, this can become a MSQ type of question. Okay. Okay. Yes, time has expanded, data is same, some zeros were padded. Now those zeros will be removed, Chirag. Correct है. Okay. Yes, Rahul. Okay, if you want, we can have a session on interpolation also. Right, not right now. कभी हम एक interpolation और ये decimation वाले methods पे बात कर सकते हैं separately. I've seen students little bit confused over that. This is done, guys. Okay, next question. 1.46. Okay, problem 1.46. Consider the feedback system of figure P 1.46. Okay, assume that yn equal to 0 for n less than 0. Sketch the output. So हम conventional नहीं करेंगे. Let us not sketch. Let us at least find out the output when xn is del n, when xn is un. Okay. Now dear, this will have the two methods. Okay, this will have the two methods. Okay, इस पे दो methods होंगे. Okay, to solve this problem. To solve this problem. Method number 1. Okay, somebody can solve it using the Z transform also. But आज हम Z transform पे नहीं है. Okay, so method number 2 is by pure logic of equation. Is by pure logic of equation, and that's going to be actually easy. Logic से बहुत easily आएगा. Why? See, what is this yn? What is this error signal actually? Okay, yn is en minus 1, but what is this error signal? It is xn minus yn, just like the continuous time control system also. The difference between reference input and obtained output. Okay. Yes, Ghosh. Okay. For unilateral में what it is? Unilateral means only right-sided ROCs are there. If you talk about unilateral, okay. If you talk about unilateral, Kumar, ठीक है? आएंगे. Will come to Laplace also. So there all cases will come bilateral, unilateral, etc. Okay. So error is xn minus yn. So what is this? What is this yn now? As clearly mentioned, there is a block diagram that is representing first difference, that is e of n minus 1, and that will be en is xn minus yn, so en minus 1 is xn minus 1 minus of yn minus 1 minus of the yn minus 1. Okay, so अगर हम equation number 2, हम equation वाले method से जाएं, method number 2, what is yn? What is yn? That is given by x of n minus 1 minus y of n minus 1. So what is yn? Plus y of n minus 1 equal to x of n minus 1. Okay, now to convert into a gate level question like numerical answer type question, what they can do is maybe they can ask you what is y2 या y3, any one value they can ask. First case में क्या है? You want to consider the input xn. Okay, in the question number A, the input is taken as delta n. Okay, so yn plus yn minus 1 is equal to delta n minus 1. Also yn assumed to be 0 for n less than 0, causality रखते हुए. Okay, okay, so yn equal to 0 for n less than 0, ये तो given ही है. Okay, so let us start with n0. Okay, let us start with n0 then. अच्छा, yn plus yn minus 1 equal to delta n minus 1. What is delta n minus 1? Delta n minus 1 is 1 only at n equal to 1. Delta n, the unit impulse is only a 1 point signal, na? This dt domain में. Okay, so that will take the value 1 only at n equal to 1. Okay, so अगर n का value 0 रखा, so dear y0 plus y minus 1, let me write it like this, but n का value 0 है तो right hand side will be 0, y minus 1 is anyway 0, yn is 0 for negative time, so here you get the value y0 is 0. Okay, here you get the value y0 is 0. Now put down n equal to 1, एक एक करके बढ़ाते जाएंगे. Okay, so y1 plus y0 equal to, because n equal to 1, the right hand side will be 1. Okay, but what is y0 obtained? 0. तो यहाँ से आ गया y1 का value 1. Okay, if I put n equal to 2, y2 plus y1 equal to 0. Now only n equal to 1 per right side was 1. Now other time it will be 0. Other type of 0. Other time it will be 0. Okay, so y2 plus 1. So what is y2? Minus y1, that is equal to minus 1. n equal to 3. y3 plus y2 equal to 0. So what is y3? Minus of y2, that will be 1. So now understood, alternate plus minus plus minus plus minus plus minus plus minus. So what should be the value of yn? What should be the value of yn? I can simply state the answer here. What is the yn? If I want to write down in the sample form, at origin it is 0. Okay, here origin y0 is 0. Then alternately it takes the value 1 minus 1, 1 minus 1, 1 minus 1. You can sketch it also, but I have written it in the form of a sequence. हमने एक sequence बना दिया. That is the answer. Clear? Okay. Yes, infinite impulse response. Okay, now if you come to xn equal to un, similarly b part, if xn equal to un, okay, if xn equal to un, चलो ये भी complete कर लेंगे. So xn equal to un, so now you will have the equation yn plus yn minus 1 equal to u of n minus 1, but we know that u of n minus 1 will be 1 for n greater than equal to 1. n minus 1 greater than equal to 0, तो n greater than equal to 1. Okay, तो again start n equal to 0 से y0 plus y minus 1 equal to n 0 है तो right side 0, but y minus 1 is also 0. Okay, तो y0 0 आया. Okay, next n equal to 1, y1 plus y0 equal to 1. Now right hand side will be always 1 for n greater than equal to 1. Okay, तो y1 equal to 1, y0 तो 0 है. Right, if I take n equal to 2, y2 plus y1 equal to 1. तो y1 का वैल्यू 1 था तो y2 will be 0. Okay, y2 will be 0. If I take n equal to 3, y3 plus y2 equal to 1, but y2 is 0, तो y3 will be 1. So alternate, okay, ये कितना था? 0, then 1, then 0, then 1. So etc. What's my answer now? I started with 0 origin पे. Yes, at origin it is 0, then 1, then 0, then 1, then 0, then 1, and etc. This will be the answer, dear. It is alternate 0 ones. Hanji, hope you have got it. Okay, by the logic of equation, it is simple. If you want, you can solve it by the Z transform also, if you know the Z transform. ठीक है जी? Chalo, done. Okay, so time is 2 hours, 2 hours of session today. Okay, now we shall be meeting next on Wednesday. Next on Wednesday at your regular time 9 p.m. and Wednesday we are discussing similar to this the questions on LTI system. I am even okay to extend up to 2 hours, no problem. Okay, provided we solve all quality questions. Okay, all quality questions and provided your motivation is there till the end. Okay. Okay, it is all for students. So if maximum students follow, it is there for all. Okay, we can have, I told you I planned 1.5 hour session, but it went up to 2, but no problem. No problem. That's no problem. Okay. ठीक है जी, done है. So LTI systems, okay, like convolution and all those things. Discrete time convolution, continuous time convolution, all results based on convolution. That we will discuss. अच्छा. अब आज की पीडीएफ की बात करते हैं. So today's PDF as always will have a password. You will not get it. Okay, you will only get if you have watched the session. Otherwise you not able to access the PDF. तो क्या रखें password? बताइए. Password will be input. Password will be input. INPUT, everything in small. Those who have watched it, those who have given time for 2 hours, spent time, really learned, they have the password. You can access it in my Telegram group. ठीक है. The yesterday's PDF, which was on differential calculus, I think I shared on Telegram. Yes, those who followed the yesterday's session, Sunday differential calculus special session, okay, that is also shared in Telegram. I'll share this. I'll share this tonight or tomorrow morning. I'll see. Okay, I'll see. I'm right now a little tired, but if I sit on system anytime, I'll share tonight. Otherwise, morning I will share you. Okay, but मिल जाएगा ये sure है. Note down the password. That is the input. That's it, guys. And you can also get the access to the GATE crash course. Already I told you scholarship test is also live on 15th of September. That is 15th of October, Sunday. Okay, the crash course. Okay, for the fast track revision of the GATE syllabus. Okay, with the complete syllabus coverage. Okay, through live classes or recorded lectures, study material, mock test, practice quizzes, everything available for all branches. The different sets are available, and you can contact 9241333666 in case if you have any queries, any further queries. Thank you, guys. See you Wednesday. Don't forget 9 p.m. time same रहेगा 9 p.m. Monday, Wednesday, Friday will be this OpenHEM question series. Okay, OpenHEM question series. Bye bye. Good night. Stay safe. Hope you enjoyed it. If you really enjoyed it, do not forget to like. In case you haven't liked, okay, and that will just tell us the message that how you like this new initiative. And moreover, since this is a new type of initiative, completely solving a book questions here, okay, the important questions of the book, I want you to write down in the comment box, not here right now, later on in the comment box, please do write down how did you like the initiative, because based on your comments, we can have a decision whether to go for other subjects or not, okay. Like one subject already we are planning with Sanjay Rathi sir, that is network theory, okay, by Sadiko, the very good book Sadiko. Okay, so do mention in the comment box so that we can analyze and take the future decisions accordingly. Bye bye, good night, stay safe and take care.